So, hi everyone. Andrej Karpathy, the OG AI scientist and ex OpenAI co founder, in just 1 month has now released two videos on LLMs. The previous one was deep dive into LLMs like ChatGPT, which we summarized, and today he has dropped another bomb of a video that is how I use LLMs. Now the video is great. I just watched it and loved it a lot. This is not a typical technical LLM video. It is more of a superficial video to help non-AI guys to understand LLMs and their different features. But as you can see, the length of the video is again 2 hours 11 minutes. So that's huge. So for that, I'm trying to summarize the video for you in short. What are the different aspects talked about? And then you can jump onto different sections of the video accordingly. So let's get started. So starting off with the first section where he talks about basics of LLM, that is large language models. Starting off with the first model that came in, that is Chat GPT, if you remember, in November 2022. So he first of all talked about the timeline of generative AI launch of Chat GPT that happened in late 2022. First widely accessible LLM. Feature expansion, LLMs have evolved to including tool integration, internet search, code execution, file uploads, support to audios, customizable personas, memory features. So when the first version of ChatGPT came, it was just a question answering system. But now these LLMs have been integrated with multiple other features as well. Multimodality is one, personalization, tool integration, market adoption. LLMs move from experimental tools to practical applications like education, coding, healthcare, etc. Not just OpenAI, there are multiple big tech players now in the generative AI market, that is Google Gemini, Microsoft Copilot is coming, Meta's Llama, and many other. And not just big tech, even startups are there like Anthropic, you must have heard of it, from to which Claude belongs to. XAI, DeepSeek, these are some major names in the generative AI space. So basically, the first few minutes of the video talks about the history, sort of the what happened in 2 years, who are some major players, and global expansions like Mistral is also there, which is coming from France. DeepSeek is coming from China. Now talking about differentiation and market dynamics. So each model that every company has released differs in some way or the other. For example, Claude 3.5 is great for technical tasks, while Gemini is optimized for speed. Some provide free LLMs, some are open source, but some are paid. So he's talking about different aspects of generative AI and especially LLMs. Tool integration, some models provide tool integrations like Claude artifacts if you have used. Some provide internet search, file upload, code execution, etc. Not just LLMs, there are also leaderboards that have come into the picture where now you can go and check the performance of the models. So he has taken some backdrop towards what has happened so far. And then he has also mentioned what are some good models in each of the domain. Like for example, coding, Claude is great. Math and logic, GPT-4. Multilingual support, Gemini. Implications for user, choice versus complexity. So which model should you use? More models means more options, but also more trade-offs. For example, right now also, even though GPT 4.5 which has released today didn't do well, Chat GPT remains the most established and feature rich option. If you search on the internet what is the usage of Chat GPT compared to others like Claude or DeepSeek, it's a huge gap. So use case alignment, users also experiment with different models based on the need. So I think in the first few minutes I just tried to set up the base, what has happened so far, who are the major players, and how are people choosing LLMs. Practical applications of LLM. In the second part of the video, as he's moving ahead, he talked about what are the basic inputs and the output. So basic interaction is using text input and text output, and the smallest tokens that goes inside an LLM is called as a token. How does tokenization work? Text is split into tokens. So whatever sentence you are inputting, it would be broken into subwords, words, punctuation, then converted into numerical representation, and the response is generated. So this is just to explain the layman understand how does an LLM work. Talking like, then he has given an example as well. Write a haiku about being an LLM. Then tokenized input would look something like this. Each word would be broken down, and the model response would look something like this. Tokenized output is 19 tokens. So whatever has come as an output, that is also coming out as a token. So he's trying to explain the layman understand how does an LLM actually work, just from a superficial line. He's not talking about transformers and attention. So leave on that. Practical implications. Shorter prompts generate faster responses. This is actually correct. Clear specific prompts provide response quality. And understanding tokenization help user optimize interaction with LLM. And I think that is why he has mentioned tokenization in the next part of the video. Tokenization, the foundation of LLM processing. So he has first of all talked about some key concepts also to understand around LLMs, that is vocabulary size. GPT-4 has a vocabulary size of 2 lakh tokens, allowing for a broad representation of language. GPT-4 can understand 2 lakh tokens, different tokens. Tokenization algorithm like byte pair encoding and other algorithms are also there, might be used. Special tokens are present. End of text user assistant. So if you have been coding using LangChain, or if you are writing some prompt, you might have seen this user assistant thing. So these are certain special tokens to identify that the user part has started in the prompt, or the assistant part has started. So he's talked about a bit on the tokenization part as well. We would be skipping this part. Example using tokenizer won't require. Why tokenization matters? Why he has mentioned that efficiency breaks rare words into known subwords. Like neural GIA would be broken into neural and GIA. So you might not be knowing about GIA, but you might be knowing about neural. Hence, the LM would be able to understand half of the word, if not fully. Context management and tool integration, tokenization, precisely handling of code calculation and language translation. Conversation format, structuring interactions with token. LM processes conversation as a continuous sequence of tokens. I think this we all understand. So when you input a sentence, that is a sequence of tokens only. Now he's talking about the conversation structure. This is very important because you might have seen multiple examples if you have worked with LangChain or any other framework where you're providing system prompts and all. So he's talking about the conversation structure, the structure of the prompt. User message, this is the special token he has mentioned, and then your input, and then the user, ending the user input. Same goes for assistant, that is the AI message. This is the example he has given now. User, write a haiku about being an LLM. Assistant, words flow like a stream, endless echoes, etc., etc. So this is how there is a internal working of LLM that has been shown, and that is why most of the time you would be using these formats when working with the framework. This format ensures that the model correctly tracks conversational roles and maintain context. Context window, managing memory and conversation. So this is a very key element, memory. So context window, the model's working memory, storing a fixed number of tokens. Resetting context, starting a new chat clears previous tokens. So if you have been using chat GPT, for example, you are able to question it around the output that it has given previously in the chat. But once you start a new conversation, the memory gets wiped off and you get started again. So it can't talk about the previous conversations it had. And every time for every LLM, there is a token limit for memory. Practical use cases, multi-turn dialogues. Why memory is important? Because you are having a long conversation. Tool usage includes external data, search results, and then you want to do something over the search results. So basically, you would be taking the input from the previous conversation and then applying a tool. Error handling is also important. LLM training process. This includes, the first part includes pre-training, compressing the internet into parameters. I think very well said. So LLM starts, how an LLM model is trained. LLM starts with the process called as pre-training. It's like you are taking the all the world's data, whatever the biggest data possible, and then providing that information to the LLM. As he has mentioned, this stage functions like a compressed zip file for the world's knowledge, and that is why LLMs knows everything. Data scales and source. Models like GPT-4 train on trillions of tokens, right? And websites, code repository, they are trained on almost everything. Internally, they use an architecture called as transformer. I think on this channel we have covered transformers a lot. But if you're a non-AI guy, transformer is sort of a machine learning model. Uh, and let's not talk much about it. It would be very complicated to understand transformers in this particular video. This is more of a superficial understanding of LLM. Training is unsupervised, meaning the model learns pattern without explicit label. This is very important. You're not providing it an output. Okay, train for this output. You are just providing it the data, read and understand whatever you can. Parameter compression. The model compresses the knowledge, all the text, all the website, all the codes into numerical matrices that are called as neural network parameters. So you must be hearing that Llama 70B. You might be hearing that GPT-4 is having 150 billion parameters. So that B, 150B means that 1 billion neural network parameters, weights, the knowledge that the LLM has. GPT-4 has 1 trillion parameters, storing learned features like word relationships, and factual knowledge. Knowledge acquisition. The model learns associations and stylistic patterns. Paris is the capital of France. Like it is able to associate ki Paris is dash of France, that is capital, and stylistic pattern, like whether I should be writing formal or I should be writing casual. This is all because of pre-training part. However, pre-training is probabilistic, meaning responses are based on likelihood and not absolute facts, leading to occasional hallucination. So I think you might be hearing of problems like people asking it, who won 2023 World Cup, and eventually the name pops out as Sri Lanka. So this is called as hallucination. So what happened? This is all mathematics going on in the model. The model actually doesn't understand everything. So in that case, when the probability goes off a bit at times, associated values, like for example, it won't be giving you an output like Zimbabwe. It would be giving an output like very close nation which might have a chance. So as the systems are probabilistic, they are not absolute. You would be facing problems called as hallucination. That is, the LLM would be lying to you. It would be creating facts on its own. Cost and limitations. Extremely expensive to pre-train a model, and models are rarely retrained, leading to knowledge cutoff. So you might have heard of GPT saying that I have a knowledge cutoff of October 2023. This is because pre-training can't happen regularly. Post-training is specialized for human interaction. So once the pre-training of an LLM is done, post-training is done. Models are trained on datasets with human annotated conversation. So right now we have trained the data or trained the model on some every data that we got, and we didn't provide it any conclusion ki, okay, you need to output in certain way. Now in the next step, that is the post training, would be training the model on conversational data. If we would be providing it to answer in conversations rather than this outputting one token at a time. Persona adaptation. Post training teaches model to adopt personas also, like become a teacher, become a customer support agent, what you do in your prompts. This is because of post training. And task specialization. Post training or fine tuning helps the model to improve in specific areas like Q&A, code generation, creative writing. That's it. So what happens basically, every model is pre-trained first, and then depending upon the use case, it can be fine tuned for that particular use case. Reducing hallucination. Human label data reinforces factual accuracy. So post training also helps in reducing hallucination that we talked about. Knowledge cutoff, the limit of pre-training. Why this exists, as already mentioned, LLMs can't be, as data is coming every day, you can't pre-train LLMs every day because it is very very expensive. Hence all the models have a knowledge cutoff. So what is the workaround to update the LLMs with the latest knowledge? I think the real-time internet search tool integration that our users should cross-check. That's the only thing. I think internet search ability is now available with most of the platforms, and even you can create an internet agent. So quite easy. Now with knowledge cutoff, there is an issue of ethical consideration. Outdated knowledge can introduce biases in sensitive fields like medical, law. Our users must be aware of this limitation. They should not believe everything that is coming from LLM because they are trained on old data. Like for example, if you are in 2030 and you got an update around internet on the LLM was trained on an article from 2020, it would be obsolete. The knowledge would be obsolete. Hence, knowledge cutoffs is an important information you should be knowing. Practical tips for using LLMs. Context window, managing token sequences for efficiency. The context window is an LLM's working memory. It's like RAM, right? You need to use it somehow. The prompt that you're providing should be very, very optimized. Because why does it matter? As he has mentioned, LLM processes text token by token. Overloading the window with irrelevant text in your prompt, you're copy pasting everything will lead to reduced accuracy and increased latency both. The output quality would be bad and the time taken would be high. So you need to somehow make your prompt very precise and very accurate. What are some best practices? Keep your prompt short. Reset your window. Start a new conversation when switching topics. This is very important. Else your LLM would be mixing up things. Be aware of token limits. Most models have a token limit of 4096 tokens in one prompt most of the time. Talking about example, inefficient use, user pastes a 1000 word article into context window before asking for a summary. The model struggles to process excess tokens, producing a generic or incomplete summary. This is something that I have faced a lot when you paste out an entire research paper and ask it to summarize. Right. Efficient use. User copies only key paragraphs into context window. This is very important. You are selective in copy pasting. So some manual labor is going on, but your answer would be very accurate. So this is one of the examples that Karpathy has mentioned in the video. Model selection, balancing capabilities with cost. So there are so many LLMs. People usually ask me which LLM should we use, which API should we take up. So multiple things. The first thing that I come to my mind is also free and paid. So models usually come in tiers. Free tiers, basic models like GPT-4 or Mini, Claude 2 are present with limited features and limited quality also, right? Paid models like Claude 3.7 has come, GPT 4.5, these are paid and these are great in terms of the quality of the output they produce. So depending upon your use case, I think that should differ. Trade-offs, cost versus performance. Uh, GPT-4 that is $20 per month and Claude 3.5 that is $30 per month are costly but highly accurate. So if you're working in a field which requires high quality output, I think you should be paying these amounts. I no doubt about it. Task specific needs, if you're going for coding, choose out the LLM which is best for coding, like for example Claude 3.5. For research, models with internet search are better, like Gemini 2.0. For creative writing, smaller models suffice. You won't require a huge model with paid subscription to write emails and write poetry. Most of the common models would be able to do. For example, a developer debugging complex code should be using GPT-4 or Claude 3.5, while a student summarizing a textbook chapter might be good with a free tier model. So this is how you should be choosing your LLM. Tool using enhancing functionality with external tools. So I think the most popular to external tool is internet search. I think Perplexity is the biggest example where they have integrated LLM with an internet search that took a boom. The model generates a search query, retrieve results, and use them in responses. This is how an internet search works. For example, the user asks, "What is the next SpaceX launch?" Model searches the internet, retrieves a schedule, and responds with accurate information. Python interpreter. So, not just generating code, such a tool can be used for executing codes as well, right? And returning the result. So, this is examples of tools that can be created. What is a tool? Calculate the integral of x square from 0 to 5. The user asks, the model generates and runs the Python codes and return the answer. File upload, this is also again a tool. Process the such a tool can process PDF spreadsheets. I think these is common tools that are present with most of the UIs, be it Chat GPT or be it Grok, be it DeepSeek. How it works: uploaded files are converted into text and then added to the context window. So in this particular video by Andrej Karpathy, I just tried to mention out the different key features around LLMs that has been built out and its history. So you should, it's sort of summarizing what has happened in the last 2.5 years since ChatGPT has come in, and what a great video, to be honest. He has almost covered everything. Additional tips for effective use: custom instructions, define model behavior, tone, verbosity, or response style. You should be mentioning whether you want a formal email, how long the answer you wish to have, what is the expected output format. Memory features: some models can retain context across sessions also. And multi-model input: some of the models can use input as audio, image, and video also. So do use that as well. Now moving on to the next section of the video, that is advanced features. So here he has talked about the thinking models. So you might have heard of deep research coming from OpenAI Chat GPT and DeepSeek R1 also. So he has talked about that also. Thinking models, deep reasoning with reinforcement learning. So how such a model is trained? I think we have covered this in quite some depth while discussing the DeepSeek R1 paper. So I'll just try to wrap it up quickly. First of all, pre-training happens, training the model on every database that is known. Then supervised fine-tuning, human annotated conversational data, and then the last step is reinforcement learning that happens. Right. So this is not the case for the generic LLMs, but in case of reasoning, this would be required. And I think most of the LLMs have now started using reinforcement learning. What are the capabilities of reasoning LLMs? Multi-step reasoning, error correction. So most of the time when the LLMs with reasoning capabilities are good with mathematics or science problems, and domain specialization, effective in maths, coding, and logic based tasks. Access and cost, I would be skipping this example part where reasoning models can be used: logical puzzles, code debugging, math problem, etc. SS access model selection, GPT-O models O1 and O3, Claude Sonnet tier, DeepSeek R1 is free. So these are the free models. Pricing is also there. Usually they are paid, but DeepSeek R1, since it has come, it is free. So you can use that too. Practical tips: enable thinking mode while you are using models in ChatGPT. Also, there is a thinking mode, if you have seen. Enable that for if you are solving some complex problem, and be patient. Deep reasoning takes time. It is a lot of tokens that the model is outputting, so you need to be patient. It can't be quick. Internet search, assessing real time information, how it works. So he has explicitly explained how does the internet search tool works. Trigger search, the model emits a special token when it detects a need for current data. So I assume it to be like how perplexity works. So once the model takes up your query and thinks that internet results are required, it emits a special token. Then internally some code is written that execute the Google search and gets you the results. There are different use cases, like making news around recent events, dynamic data like stock price, weather, etc., niche topics. Model support, I think now most of the models support internet search, at least in the UI, so you can play around with it. Limitations: source reliability, results may contain hallucinated or misinterpreted data. So if some random guy has written a blog on, say, stock market, you are into trouble, my friend, because the LM would be able to make out how great the resource is, right? So it is scraping the internet, whatever it gets it will summarize that. Latency usually slow. Now talking about deep research, which was released by Google as well as OpenAI recently. How does it work? Deep research combines internet search, multi-document analysis, and structured synthesis to generate detailed reports. So the process looks something like this. Query analysis, whatever the user has prompted, it goes into the LLM, it breaks it into subtopics. Web search happens. Document processing, extracting key information from the research results and producing a final structured report. It is useful in many domains: healthcare, market analysis, technical deep dives, etc. How is deep search available? ChatGPT is providing that. Perplexity is providing limited free tier deep research capabilities, and Claude 3.7 plus deep search in Claude 3.7. Limitations, I think cost. It's costly because it is going through a lot of research. It is generating a lot of tokens. Accuracy, again, hallucination would be everywhere, and processing time is also very very high because it is generating an entire report. It's not just an output, right? Now moving on to the next section, that is multimodality, what he has discussed a bit. So multimodality includes that the model is able to intake audios, videos, images usually, and then output also if it can in different modalities. Like it can output audios also, it can output videos also. Most of the time it's not the case, but ideally that should be a perfect multimodal LLM. So he has first of all talked about audio interaction, speech to text and text to speech, STT, speech to text. He has first mentioned that audio is converted into text tokens using speech recognition algorithms, and tools like Whisper are integrated with ChatGPT in real time. So basically, if you have used the audio mode of ChatGPT, it's like it takes your audio, it converts it into text, and then it goes to the LLM. This is how a speech to text LLM work, at least in this case, what is mentioning about ChatGPT. User speaks, why is the sky blue? Model transcribes the audio, processes it, and responds. The sky appears blue due to Rayleigh scattering, etc. Text to speech. The model text response is converted into audio. It's very, very similar. So, how does ChatGPT is also able to talk? He has mentioned that there are multiple apps. So, it's take it as a tool only. Like the model is generating some text, and eventually you then apply a wrapper over it that converts the text into audio. Advanced voice mode, true audio. That was in case of chat gpt. If you use advanced voice mode, it's quite good. Unlike standard STT and TTS, where you are using a third party, it's not integrated within the LLM, right? You are using a third party tool. Like for example, Whisper is a third, it's another model which you are integrating. Advanced voice mode processes audios natively, so it is able to handle audio within itself. It's a single model which is able to handle audio as well. This is what is advanced voice mode in ChatGPT does. Limitations, I think we all know, with audio background noises, their latency is an issue. There would be certain lags when you are outputting the answer from the model, or there would be accuracy issues also because you need to be in a quiet zone when you're talking to ChatGPT. Image and video processing, beyond moving beyond text. Image tokenization, image are how an image goes into an LLM. Image is split into patches, small grids, and patches are quantized into tokens. So token, as I already mentioned, are smallest units that goes inside an LLM. So they are now somehow making a way where every different data type can be converted into a token rather than feeding everything into the model, right? So somehow You devise an algorithm that converts the data into token, and then you have a pipeline for token to text. For example, models like Delhi generates an image from a prompt. A cyberpunk dragon is a neon city. Video interaction. Video frames are processed as sequence of image tokens. So extending the image case that we had, and then you would be dividing the images into patches, and then eventually, if those patches would be converted into tokens and fed to the LLM. This is what multimodality all about. Practical applications, I think we all know. Healthcare, analyzing medical images. In education, it's very, very important. Creative industry is taking a boom. YouTube videos are coming out. People are making posters. Everything is possible. Accessibility, voice control interfaces for users with motor impairments. Image to text tools for visually impaired users. Many things can be done using multimodal features. Coming to quality of life features. Of these modern LLMs enhance user experience through features that improve personalization and efficiency. So first of all is memory, context retention across conversation. I think we have already talked about it. The model store key details from the previous conversation in a memory bank, sort of a database only. The stored memory is tokenized and included into the context window, ensuring the model references past information. So it is again a third party service. Just think about it like this. It's not a part of an LLM, but you are using a database where the LLM fetches information about your previous conversations, and then that is getting included in the hindsight in your prompt. So if you're writing, hey, what are you doing? Apart from that, your past conversations history is also going into the prompt in the backside. You don't see it. This is how example goes in. What is the capital of France? Paris in the memory. Added to my travel it refers to Paris. So the model is able to understand it from the previous conversation that it refers to Paris. Use cases, I think personalization is one. Task continuity, contextual understanding, right? When you're talking about it, they, etc., the model would be able to make out. Tools and management. Memory updates automatically. You have seen this update in chat GPT. I'm quite sure that memory is updating. There was quite some memes on this. Customizations, users can edit, delete, add memory as well in the settings. Limitations, model is memories model specific data is not shared across platforms. So there's a limitation also, and there is an issue of data leakage as well, because now your personal information is present with the chat. This is very, very personal. It knows about your personality. Route. Custom instructions, tailoring model behavior. So in chat GPT, I think you might have seen a section in the settings where it says that you can now customize it according to you. So for example, if you want it to answer as a teacher, you can just mention that as a system prompt. This is what is meant by custom instructions. User provide input preferences in dedicated setting panels. Instructions are tokenized and added to the context window every time. Like for example, the user sets always provide code in Python. So when he asks, anytime he asks, give me code for palindrome, the LM would understand that he's asking about Python. Many use cases are there, and most of the tools, like in ChatGPT, you might have seen custom instructions. It is present. Claude persona settings are there. Custom GPTs, task specific model creation. Custom GPTs is a new section that is in and that is introduced recently in ChatGPT. If you have seen, so basically, these are GPTs for specific task, niche task. How it is works? Define instructions. The user specify task and provide examples. Explain vocabulary from Korean sentences. Few short learning model learns from 3 to 5 examples and deployment. So basically, LLMs for very, very specific tasks, and they're not fine tuned most of the time. They are having some custom instructions, or like they have some wrappers around them to produce a specific task. Many use cases are there. There are multiple things. You can read this in the particular blog. Benefits of custom GPT is quite much. Avoid re-entering the prompt every time. I always want the code in Python. Why would I write every time, okay, give me code in Python? Just make it a system prompt or make it a custom GPT thing. And personalization is there. So concluding, this was very, very long. I'm tired now. My throat is thirsty. I just wish to drink some water now, but it was such a ride. It was a wonderful video. And if you get some time, I would highly suggest you to watch it, because it would give you a practical understanding of how to use LLMs. Thank you so much. I hope you like this summary.